I'm Yuanhan from Tencent, and today I'm going to talk about Vswitch upgrade. And here is like the agenda. So firstly, I give like a bit introduction, and then it's all about like how to make it faster, and then make it faster. So the whole key point here is actually about the upgrade, and why we do that actually is quite clear that we have to like fix bugs, and also we add new features like sometimes. So the key point here is actually we have to do the upgrade fast because it impacts VM networking connections. So when talking about multiple process, when talking about upgrade, a lot of people actually mention multiple processes, but I don't think it is a good solution. And why is that? Before telling the reason why, I think it's necessary to understand like how multiprocess works. And here is a simple version. And the primary process will initialize and configure the port, and then store some key information like into a private data structure in the NIC driver. Let's call it like a NIC private. And then the second process will it could skip the initialization and config, and then get like the port information from the NIC private, just like filled by the primary process. So you can see that it shows the same data structure, so the data structure has to be the same between the two processes. And if you switch like a new version, it will not work. It simply will not work. And that is the key issue. And well, it also has like ABI and API issue. Well, we break APIs and APIs almost like every release. So you see that is quite fatal because it makes painful for switching DPDK versions. Therefore, it's not good for long run. So what we should do, like if multiple processes is not a good solution, so my opinion was we need to figure out like what slows down the startup. And it turns out to be that, well, I mean, we have talked about the memory, huge page memory initialization these 2 days quite many times, and here's one more time, that the old DPDK allocates all huge pages, I mean 3 huge pages, and then freeze the rest. So, and here's an example. You can see that, okay, so in a system with like 60 gigabyte huge page, and here is a time to start a test PMD. Well, the test PMD will do nothing because because this kind of stuff like invalid arg. So you will just like init and then quit. And you can see that the time here is like almost 12 seconds. Well, that is long enough actually. So why is that? Because here is a time for like allocate a one gig huge page, and you can see that it's almost like 200 milliseconds. That's too long for even for like one single huge page. So what should we do with that? I mean, and well, I came up with a solution. Well, it's like more like maybe a workaround or whatever. So the basic idea is we populate a huge page before starting DPDK. So what time spent there is actually not accounted for the startup time. And also I introduced like a memo file, like a new option. And so DPDK will only allocate memory from the given files. It will not like scan all the huge pages. And the memory size is retrieved by the F state, so you don't have to like specify like how many huge pages you want to allocate. So, and here's a, oops. So reserve huge page is a simple program I wrote, which is actually just calling, I mean, the map function, and also with a populate flag. So when you run the program, I mean, the kernel will allocate the huge page for you, and the later parameter is size. The second parameter is the size, and the last parameter is about the node. So what it does is basically allocate 2 huge pages, which each one with like 1 gigabyte and on 2 different nodes. And then we fed the 2 files to the DPDK, and then it will go, and you can see that the system time is just about like 9 million seconds, and the total time is like 226. Well, that's good, actually. So what else? I mean, here actually I list few of them, and what is actually quite trivial stuff. I'm not going to say I'm always have a good solution, or I'm not going to like list all the solutions to all of them, but I just want to share something what may interesting or even surprise you, especially like this one. LSPCI, like in a server with quite many, PCI devices may take up like 50 million seconds, and a port may take more than 100 million seconds, and a config and start a device may also take like 100 million seconds. And the reason I say may is that depends. That window depends, and so that's the reason may. And also for membuff memport, if you have like a large membuff memport, it's also time consuming because it will go through the big chunk of memory to construct all the membuff instances, and which might also take a few hundreds or million seconds. So how to make fast? And in the left, you can see like a short figure actually. So this is like quite a common way to upgrade a program, which just do restart, and first you stop it and then restart it. And here, this is like how the Vswitch restart works. Firstly, there is like a signal for stopping, and then the Vswitch will stop, and then maybe there's some post scripts to do like cleaning up jobs, and also for the start there might be like a pre-start script, and then you see the familiar procedures like EL initialization and port initialization, and also Vswitch initialization, and then Vswitch could start working. And so how to make it fast? Well, one thing is that you can make the post, stop, and pre-start the two scripts as lightweight as possible. For example, you can put everything possible before sending the stop signal, including the one I mentioned before, LSPCI, because sometimes you need to get what kind of PCI device you need to drive on. And also the huge pages allocation. And also parallel initialization also works actually, helps a lot sometimes. So if you, after applying all this kind of stuff, actually it can go 400 million seconds. So the new question is actually, is that okay? I think it's being okay. Why? Because if you do live migration, it may also take a few hundred million seconds, so it's okay. But is that good enough? I don't think so. Why? Well, it's simple actually. This kind of solution, you don't have really, big room for keep improving the further. Something like, well, you could use a trick to save a few million seconds, but somehow it may break something else. So it's kind of dangerous. And you also, adding new features is very likely will break down, put the downtime longer again. So it may not flexible. So we definitely need to look like a new solution, something totally different. So what's that? So, well, I somehow got an inspiration, can we do that live migration? Can we not stop the old process yet, and then we start a new one? And when the new one is ready, we do the switch. So if we can do that, I think the time should be short, and also more important, it should be constant. Adding some new feature will not likely put it longer. So, but anyway, not anyway actually. So But actually, it's more like a backup model instead of like migration. So I will just call it like backup from now on. And so the key issue, like how can we do that? I mean, starting two DPDK like in the same host. The first issue comes to mind, maybe quite clear, is that how can we start like two DPDK on one NIC port? Well, a simple solution is that we could create like two VFS, like one per instance, and then we could configure the NIC to steal package to the right VF to do the switch. That is for the NIC part, and another part is for vHost user. And we also have a simple solution for that. Well, we just stop the vHost user from the old Vswitch, and then we restart vHost user from the new switch. That is quite straightforward. But the drawback is we have to reconnect all vHost devices one by one, and that may also take some time. So here is like a beta one, and actually quite a beta in my opinion. So assume we have two processes. A is the old one, B is the new one. So for the old one, we pack all vHost devices information, including like the negotiated features and main table, viewing, all the kind of stuff, and also including the vHost user socket connection with QEMU. And then we send all of them to B by Unix socket. And one important thing here is the file descriptors will also be parsed thanks to the ancillary data. And then when B receive all the data, and it will do unpack and reconstruct all the vHost devices and also the socket connections. And here is a step for construct one single device. How to do that? Well, we allocate a new device, and we remap the vHost memory, and we retranslate the viewing address based on the new mapping. And we also add the socket connection FD back to the event loop. Now it's ready. You can start like transmitting and receiving packets. So this one and this one make sure that the vHost user socket connection is well kept, meaning there is no point for reconnect. That is a really good thing, actually. So here is a big picture for the backup model. And as I said, we have like two processes. A is the old one, and in here is also the active process. And time flies from top to down. And you can see that, well, at this time, like the old one is still running, and at this time, at this point, there is upgrade signal. And at that time, B will start like initialization and config, and when all this kind of stuff is done, we'll wait there, it will like block there. And then there is like a new signal, like backup switch. And then like the old one will stop the data path, will pack the vHost devices, and then we'll send to the new one. And well, when the new one receives, we will do unpack just like I said, and reconstruct all of them and put it to the data path, and then steal the package to the right VF, something like that, and then it's ready. So the downtime here is just this part, and it could be like 50 milliseconds. Well, actually, it could be less, like something like 40, even like 20, something like this. So that is like open question, like the possibility of making upstream. Is that possible? I'm not quite sure yet, but it's proved to be like working pretty well with vHost user. And I need to prove that may work fine with like a PC-wide device. I may start someday like with like mobile net, mobile PMD to prove that. So there is a summary. So it's quite simple, clear actually. Like there has two big advantages. One is that it has like short and also like constant downtime, and more importantly, vHost user connections are well returned. And that's all. Thank you. Questions? Okay.
Okay.
Thank you.
Thank you very much, Yuanhan.